My name is Dr. Pu Suan Hui, and I'm the lead for the Mechanical Engineering and also the Aeronautics and Astronautics programs at the University of Southampton, Malaysia. Okay, so I'm very pleased that you can join us for this live session today. Okay, so before I go into the details of the two programs, I'd just like to talk a little bit about the University of Southampton. Okay, so University of Southampton is a very highly ranked university. So amongst all the universities in the world, we are ranked in the top 1%. Within the UK, we are also a founding member of the Russell Group. Now, what is this Russell Group? It is a group of very research-intensive universities. This means that we are very active in our research and we translate that into our educational programs. 94% of Southampton graduates go into employment within 6 months of leaving university. This is true true of students at the UK campus and also at the Malaysia campus. So we are very proud of this fact that our students are very employable. Now, for the whole university, we have more than 24,000 students, 17,000 of which are undergraduates, and our students come from all over the world, so more than 100 countries. And at the Malaysia campus, we have lots of students who come from overseas as well. So it is a very diverse student body that we have. There are also a lot of clubs and societies. Many of these are at the UK campus. At the Malaysia campus, we have got lots of societies that our students can get involved in as well. So this would really enhance their student experience. We have got flexible modules. So we have got online learning platforms. I will talk a little bit more about this later on. And also in terms of the flexibility of the program, there are lots of options that you can take, especially in the 3rd and 4th years. So a little bit about our illustrious alumni. We have got lots of people who have graduated from the university and who have gone on into really significant roles in engineering. So this gentleman on the left, his name is Sir George Buckley. He's the current chairman of the board at Stanley Black & Decker. So this is a very large engineering company. And formerly, he was the CEO of 3M. 3M is one of the most innovative technology companies. So you would be surprised, but a lot of household products, a lot of things that you use, tools, and all sorts of items that are found around your homes would have been designed by 3M and manufactured by 3M as well. It may not be labeled as 3M, but actually it's coming from this company over here. So right in the middle, this gentleman here, his name is Adrian Newey. So if you're a racing fan, if you're a Formula One fan, you probably know who he is. He is the current Chief Technology Officer at Red Bull Racing. Formerly, he was also at Williams F1. He was also at McLaren. And he is essentially responsible for many of the championship winning cars. So he's a very well-known individual. He graduated from the University of Southampton with a degree in Aeronautics and Astronautics. And this gentleman on the right, his name is Stephen Payne. He's a naval architect and he's the designer of the RMS Queen Mary 2. So the Queen Mary 2 is a cruise liner, but what is unique about it is that it is the only ocean liner. So it actually crosses the Atlantic. It's designed in such a way that it can withstand the very large waves that you encounter in the ocean. So very few ships are able to do that. In terms of cruise liner, this is the only one. And the designer of this cruise ship was a graduate of the University of Southampton. So now all of our undergraduate engineering programs are very highly ranked. Okay, so for this talk, I will concentrate on mechanical engineering, which is ranked number 4 in the UK, and Aeronautics and Astronautics, which is ranked number 6 in the UK. Okay, so first, I'd like to talk about the mechanical engineering program. So over here, we have an overview of some of the modules that you would be doing for years 1, 2, 3, and 4. Years 1 and 2 are done at the Malaysia campus. So now our students come onto the program with a variety of backgrounds. They would have done A-levels, they would have done foundation, they would have done, for example, international baccalaureate or some other pre-university qualification. So now in the first year, we make sure that, it doesn't matter which program you have done before university, we make sure that you are able to cope with the rigor of a good engineering degree. So all of the year one modules are really foundational modules. Okay, so to be a mechanical engineer, we start you with the fundamentals. We want to make sure that you are able to do things like design, computing. So we teach you how to program. Some students come in with some programming knowledge, but others come in with zero programming knowledge. But that is fine because we get you to the stage where by the end of the first year, you are able to write programs. We teach you, even though you're mechanical engineers, but we still teach you electrical and electronic systems. Mathematics, very important for any engineering program. More fundamental subjects like mechanics, structures and materials, thermodynamics and fluid mechanics. So this is for the first year. So going into the second year, so again, some foundational subjects, but going into more depth. And for one of these modules, systems design and computing, you actually get to do a group design project. So even at a very early stage, you get to apply your engineering knowledge. You work together in teams, and you actually build a functional engineering product. Okay, so now going into the third year, so actually there are more modules than what I've shown you here. But that's because there are some modules that are optional. So there are lots of modules that you can choose from. So the module shown here, Engineering Design and Management, this is a compulsory module that all year 3 students have to take. But on top of that, you have got an individual project and you have got 5 other module options. And going into the 4th year, this is the bigger group design project. So in a way, there are some similarities to the second year group design project, but over here, this group design project is more likely to be linked to actual research projects that are going on in the university. And in the 4th year, other than the group design project, you get to take another 5 optional modules. Okay, so now you will see that some of these modules are in bold. Okay, so that's because today I'm talking about 2 different programs, MEng, Mechanical Engineering, and Aeronautics and Astronautics, Aero and Astro. So later on, when I show you the overview of the Aero and Astro program, you'll see that these modules in bold, this is where the MEng program is different to the Aero and Astro program. Okay, so now in the first year, the MEng program is very similar to the Aero program. So what this means is that, say for a module like design and computing, in the same session, we would have both mechanical engineers and also Aero and Astro students. Okay, so this module over here, Mechanical Systems Analysis, this is only for the mechanical engineers. Now going into the second year, okay, so you see that out of 8 modules, 4 of these modules are now different across the 2 programs. Okay, so I've got 4 modules highlighted in bold. Okay, so these are the modules that only the mechanical engineers do. Okay. Okay, so now for the mechanical engineering program, in the 4th year, you can actually go into a specialist theme. Okay, so this allows you to go further in depth into one of these areas. So for example, if you are very interested in acoustics, acoustics basically is the field that relates to vibration and sound generation. Okay, and where could you apply this? For example, if you were to design a musical instrument, if you were to design a sound system within a concert hall, or for example, if you are driving a Mercedes-Benz premium car, you want to make sure that the sound is really perfect for the driver. Okay, so things like this. So if you are really interested in acoustical engineering, this is the theme that you would choose. Now, there are lots of other themes. In fact, there are 11 specialist themes that you can choose. So beginning right at the top, this is mechanical engineering. So this is the generic theme. And if you were to specialize, say, in acoustical engineering, what will be reflected in your final degree certificate, it would say mechanical engineering with acoustical engineering. Okay, so other themes that are available. So, for example, advanced materials, increasingly important. If you're going to design a more efficient plane, you're going to use more and more composite materials to replace the traditional aluminum that you would use in an aircraft frame. Okay, so very important area. So not just in aerospace, but in things like biomedical engineering, etc., etc. So now for the mechanical engineers, there is also an aerospace theme. So this allows students on the mechanical engineering program to take some aero-related modules in the upper years. And there's also an automotive theme, there's a biomedical engineering theme, computational engineering and design, engineering management. Okay, so some students, they realize perhaps from the second year project that they like to be the ones who are getting everyone on the ball to achieve a certain engineering outcome, and they think that in the future when they go into the industry, they would rather focus more on the management aspects of engineering rather than actually doing the calculations or the hands-on design. So this engineering management theme will be very good for students like that. Okay, so now there is also a mechatronics theme. This is often a very popular one, and we often get asked by potential students, now, do you offer mechatronics engineering? So the answer is that we don't call it mechatronics engineering, but within mechanical engineering, you have got a specialization called mechatronics. So over here, you'll be looking at things like robotics. You could be looking at things like, for example, the application of artificial intelligence to robotics, or applications of AI into unmanned flying vehicles. Okay, naval engineering, Southampton being a coastal city, so this is also one of our strengths. Under the MEng program, you can specialize in naval engineering if you wish to. Sustainable energy, very important topic, very current, becoming increasingly more important as we go forward, because we want to make sure that any kind of engineering solution that we make in the future, or that you make in the future as graduate engineers, these solutions need to be sustainable. It needs to look at things like, how does it impact our limited energy supplies? How do you dispose of a product without damaging the environment? So sustainable energy is going to be a very important topic and increasingly more important. Okay, so now just one more point before I go on to the Aero and Astro program. So now for our students who apply to join the MEng program, they can indicate which theme they would like to be on. So they can choose, for example, aerospace theme coming in as an applicant starting year one. But really, you don't have to finalize, you don't have to fix the theme until the second year. Because by then, you would have done more modules, you would have seen more examples of engineering problems, and at that stage, you might choose to change to a different theme instead. Okay, so our students get to finalize their theme in the second year, and then going into the third and fourth years, they will be able to choose projects and optional modules that align with the themes that they are doing. Okay, so now I move on to the second program that I said that I'll be talking about. So this is the Aeronautics and Astronautics program. I mentioned earlier that the modules in bold are the ones that are specific to the program. So over here in year one, the Aero and Astro students, they would do aircraft operations and flight mechanics. So this is a special module that is tailored especially for the Aero and Astro students. The other modules, we have seen these on the slide for MEng. That's because these are the modules over here are done together with the MEng students. Okay, so going to year two, so the two programs start to be a little bit more different. Okay, so aerodynamics, astronautics, mechanics of flight, propulsion, these are the modules that we designed specially for our Aero and Astro students. Okay, so going to year three, the modules here in bold These are Aero and Astro specific. They are compulsory modules. And on top of that, the students do an individual project in the third year, and they take 2 other optional modules depending on which theme that they are on. So I will come to the themes for Aero and Astro in the next slide. In year 4, all of the students do advanced management. They do 1 group design project, and they do 4 other optional modules. Okay, so now for Aero and Astro, there are 7 specialist themes. Okay, so beginning with the generic Aero and Astro program, and for the other themes over here, so for example, aerodynamics, so you would focus more on, how do you work out the aerodynamics of any, aircraft that you're going to be designing. Okay, so if you were to take the aerodynamics theme, what your degree certificate will show eventually, it would say Aeronautics and Astronautics with aerodynamics. Yeah? Okay, so other themes include air vehicle systems design, computational engineering and design, engineering management, materials and structures, and also spacecraft engineering. So spacecraft engineering relates more to the astronautics part. So aeronautics refers to anything within the atmosphere of the Earth, but when you leave the atmosphere, the way you design a space-going spacecraft is going to be a little bit different to how you approach the design of an aeroplane, for example. Okay, so spacecraft engineering would be things like, for example, satellites. If you were going to be involved in a mission to Mars. Okay, so how do you send your Mars rover across to Mars, and for it to be able to roam the surface of Mars? Okay, so what we are very proud of at the University of Southampton is also our ability to deliver the astronautics part of the program. Many universities are very strong in aeronautics, but very few universities are strong in both aeronautics and astronautics. Okay, so now this relates to both of the programs that I'm talking about. Okay, so we have got a really flexible program structure. Okay, so you start in years 1 and 2 at the Malaysia campus. Of course, if you had done the foundation year program with us, you would have done another year before year 1 of your undergraduate program. Okay, so years 1 and 2, you do all of those modules that are compulsory, and then sometime in the second year, you finalize your theme, and then you get to split into all of these specializations. Okay, so it is a really flexible program that we have, and really it tailors to a variety of interests and strengths. Okay, so all of the academic staff on our undergraduate programs are qualified with PhDs. So we are trained, we are equipped with a doctorate, and we are also research active. Okay, so all of your lecturers teaching you, they would be involved in research projects as well. They will be supervising graduate students, master's and PhD students. And what this means is it allows us to really translate our research into our teaching as well. So this is really good for the students who are with us in our lectures and our tutorials. Okay, so now in year 3, okay, so this is after you transition to the UK campus, you get to select an individual project. Okay, so you start to work more independently, but of course you are supervised by an academic staff, and just to give you a sense of what is available to you when you actually choose your projects. So now there are 200 over academic staff in the School of Engineering, okay? And each academic staff is required to propose around 5 projects a year. So what this means is that you have available over 1,000 project options. Okay, so our students in the year 2, they choose these projects, and when they go into the year 3, they work on these projects. A lot of these projects would be linked to the research that is ongoing at the university. So this is really state-of-the-art, problems, state-of-the-art issues that our students get to be involved in. And it could be related to any aspect of engineering. and it is usually aligned with the theme that our students choose. Okay, so for example, a student on the automotive theme would do a project that is related to the automotive area. Okay, so a few examples over here. This girl over here, Namala, she's looking at the she's looking at the aeroelasticity of the bird feathers over here. So what she's doing is that she's actually allowing air to flow across the bird feathers, and she's studying how these feathers deflect in response to that airflow. Okay. Over here, Eugene, he's actually looking at an internal combustion engine, but he is interested in actually converting it from burning natural gas, which is a limited resource, to burning biogas, which is a renewable resource. Okay, so this is a very interesting project that he was working on. At the bottom here, Heman, he's actually doing a project on vibration suppression. Okay, so in some circumstances, having too much vibration in an engineering structure, for example, a bridge or a building, is actually, it's detrimental to the users, and there could be safety repercussions. Okay, so what Heman is doing is that he's studying, how you can use active damping to actually suppress the vibration and to bring it down to a more manageable level. Okay, so now in the fourth year, our students do a group design project. Okay, so they work in teams. It is a really good experience for the students because it allows them to basically divide the roles amongst themselves. They would have someone who is perhaps focusing more on the project management side, and others who might do more programming, others who might do more experimental work, others who might do more design and CAD work. So it really depends on the nature of the project, and also amongst the team members, how they choose to split those roles. These projects are very exciting, and they are aligned with our research, just like for the third year projects. Very often, companies come in, from industry, and they approach the university and they say that we have got this project, this particular problem. We think that it is actually suited for finalists or perhaps even third year students. So these companies then open up these opportunities, and working together with our university academics, they craft up this project and they make it available to our students. So lots of our fourth year group design projects come about via our industrial linkages. Some of our fourth year projects feed into external competitions. Okay, so I'll show you one example of such a competition on the next slide. Okay, so this is the Formula Student Competition. Okay, so it is an international competition. It's jointly organized by the Institution of Mechanical Engineers in the UK, IMechE, and also SAE in the US, used to stand for Society of Automotive Engineers, but now I think it's just called SAE. Okay, so students from universities all over the world, they come together and they design and they build a single seat racing car. And depending on where the competition is hosted each year, they will bring their cars over. And there are a number of categories that you could participate in. For example, you could take part in the static category, where the judges will look at how you have designed the car and consider all aspects of the design and give you marks for it. But there is also a dynamic test or dynamic section to the competition. Okay, so if you enter the dynamic section, what you have to do is you need to get a good driver from within the university, and you actually perform a series of maneuvers, and you actually go around a circuit as well. And this is timed, this is evaluated against things like precision, etc. And you are given marks for how well the race car performs. Okay, so the University of Southampton, we have our own Formula student team, and there is also a website. Okay, so you can actually look at this website for more information around the vehicles that we have designed. Now, year on year, our students improve on their designs. So just like a Formula One team, so every year you don't really start, with a blank piece of paper. Okay, so you have got a certain set of specifications that are given to you, and then you work to those specifications and you design the car according to the rules, and then you take it to the competition. Okay, so that is the reason why a lot of our students end up working for Formula One companies. Okay, that's because our students get the opportunity to really develop their skill set even before they graduate. Okay, so now we offer our students a very vibrant learning environment. Okay, so we couple what we deliver in our lectures, tutorials, and seminars with practical lab sessions and also hands-on opportunity via the group design projects and also the individual projects. And these are supervised by academics who are all experts at their field. Okay, so they are really working at the cutting edge of their areas, and they are translating these into projects that our students get to be involved in. I'll show you a few examples of projects that our students get involved in. Okay, so over here, this is a group of students who are specializing in acoustics, and they are using a specialized lab known as an anechoic chamber. Okay, so anechoic, what it means essentially is that it is anti-echo. Okay, so it prevents echoes from being generated, right? And what they are interested in studying is, if you have got aircraft engines and if you mount them at a certain location, whether it's above the body or it's below the wings, how does that affect sound generation? And how does that affect how it's perceived from someone who might be on the ground, on the surface of the earth, as the aircraft is flying above? Okay, so they are using the anechoic chamber, which is a very specialized facility. Very few labs and universities in the world actually have got this acoustic anechoic chamber. This is located at the ISVR, the Institute of Sound and Vibration. And over here, you can see that the students, they're actually mounting these model engines on a blended wing aircraft. Okay, so and this is really a very good opportunity for them to actually use the facility and to get the data that they need for their group design project. Okay, so this is a picture that is taken from our wind tunnel. Okay, so the R.J. Mitchell Wind Tunnel is a facility at the UK campus. It's one of the largest wind tunnels that a university has. And other than doing, aerodynamic tests for race vehicles or for aircraft, we also use it to test elite sportsmen. Okay, so over here we have a cyclist, and you would appreciate that aerodynamics is going to come into factor. Okay, so depending on the posture of the cyclist, depending on whether he's crouching one way, depending on whether his head is lowered or lifted, all of that is going to have an effect on the aerodynamics, and all of that is going to matter. Okay, when between first and second place, it could only be a split second. Okay, so that's why the British Olympic team, they are very interested in using facilities like ours to test the aerodynamics of their elite sportsmen. Okay, so you may or may not recognize this cyclist. If you are a sports fan or if you are a cycling fan, you may recognize him. His name is Sir Chris Hoy, and he's basically the most decorated British Olympian ever. So of all of the British athletes, he has won the most number of golds. And this was him in our wind tunnel and doing the test. And he actually went on to win a few gold medals after that at the Olympics. Okay, so we can say that our university actually helped him to achieve those gold medals. Okay, so now air is a fluid that aircraft, elite sports cyclists, and aeroplanes, they encounter as they move. Now, but for ocean-going craft, for example, boats, canoes, ocean cruise liners, you are looking at a different type of fluid. So it's not air that you're cutting through, but it's water that you're cutting through. Okay, so at the university, we have got a very large towing tank. It is highly specialized facility. Very few universities have this. In fact, this towing tank is one of the largest university facilities in the whole world. Okay, so you can see the size of it. Okay, so we have got some group design project students. Some of them are standing on the bridge over here. Others are actually on the corridor. There's one guy on the corridor over here, and they are monitoring this boat that they have designed. Okay, it's embedded with some sensors. It can be operated remotely. Okay, so you can see that it allows our students to use the towing tank to test their model craft. And this water over here, you can actually have it without any waves. You can have it still, or you can also generate some waves, to better simulate the actual conditions that any boat or ship is going to experience out in the open sea. Okay, so the size of this, you can imagine someone actually being able to canoe through this towing tank. So it's a huge facility and it's really, really impressive. Okay, so a few other projects, maybe more specialized, more related to the aero and astro students. Okay, so just to highlight, our engineers have designed and flown the world's first 3D printed aircraft. So actually this was quite a few years ago. So this was actually back in 2012. The engineers who were involved in this, it's basically a team of academics, PhD students, master students, undergraduate project students as well. Okay, so this is a very good achievement that they made. Another group of students, they were involved in designing a high altitude glider. And this glider was actually launched using a meteorological office balloon, which allows this glider to go high up into the atmosphere. Okay, so way higher than, say, a normal aircraft would be capable of achieving. And then subsequently, it's launched and it glides back onto the surface of the Earth. It is embedded with lots of sensors and also a GPS tracking device. So our students are then able to track the motion of this glider and to retrieve it and to get the data and to analyze it. Okay, so again, a very interesting project that our students were involved in. Okay, so this is an image of a flight simulator. Okay, so this is available at the UK campus. It is a really immersive flight simulator. Okay, so if you were to design a very novel spacecraft, sorry, a very novel aeroplane, what you can do is you can actually load it into this flight sim, and you can actually fly it, and you can actually input various design parameters, and you can actually get a feel of how your aircraft is going to behave. Before our students go over to the UK campus, so even in years 1 and 2, we have got another flight simulator that is available at the Malaysia campus. So this allows them to really build up experience using a flight sim before they actually go into the projects, before they use this full-scale flight sim that is available to them. Okay, so here's an interesting project. It's a group design project, and you can see that this is an aircraft, but what is unique about it is that it is human powered. Okay, so there's a guy inside this airframe, and he's really pedaling furiously, and he's going as fast as he can. And what you can note is that this aircraft is actually capable of taking off. Okay, so it works. And some of his friends are chasing him from the back. So one guy on the bike, another guy running furiously. But you can see that really the excitement on their faces, seeing that what they have been working on for a whole year is actually being put to test, and you can see that the joy in their faces, because they are noting that this human-powered aircraft actually works. Okay, so we have got a light aircraft as well. So as part of one of our research projects, one of our professors secured the funds to buy a light aircraft. So this aircraft, you can fly it manually with a pilot sitting within it. But you can also switch to autonomous flying. So I think as part of this project, what they are really interested in is, how do you fly this aircraft autonomously? So that is the kind of research that we are doing at the university. Okay, so now lots of group design projects are featured in an annual design show. And some of the second year projects get featured in this show as well, but the majority of the projects come from the fourth year group design projects. And you can really see the whole spectrum of projects that our students get involved in. So over here, this is acoustic horn. Over here, this is a Mars rover. Over here, this is the Formula Student project. This is a submarine, and this is another UAV project, fixed wing aircraft that our students get involved in. This is a space engine. And you can see that this is really a good experience for the students because they get to work through the projects, and then at the end of it, they've got this highlight, this design show, where they showcase their projects to a number of visitors within the university, but we also have got some external representatives from various companies coming in. One of the awards is sponsored by Shell. Okay, so Shell gives an award to the top performing groups. But what this really means is that our students, they develop those teamwork skills, they develop project management skills, and they also get that real interaction with industry. So this really helps them to build the networks, and it explains in part why our students are so successful in getting those graduate jobs. Okay, so now in terms of professional recognition and employability, so we are very proud to say that our degrees are all accredited and they are very well recognized by top engineering companies. So the mechanical engineering program is accredited by the Institution of Mechanical Engineering, MEng, and our Aero and Astro program is accredited by both MEng as well as the Royal Aeronautical Society. So the 4-year MEng, Master of Engineering courses, they meet the requirements for a graduate to then be able to apply for chartered engineer status with a little bit more working experience. In some cases, some of our students, they exit after 3 years with a BEng qualification. So now if you exit with a BEng, you can still go for a chartered engineer status after you do another 1-year postgraduate master's program. And so this is basically to allow you to bridge the gap between the 3-year BEng and the 4-year MEng. Now, some students, they exit with a BEng for reasons like, for example, they wish to start working earlier, or they wish to go into a different field. So for example, some of our engineering graduates, they end up going into finance. So in such situations, for a student who thinks that they want to go into banking instead, it may not be necessary for them to do all 4 years. They could exit after 3 years with a very good degree from a good university, and they get employed in all sorts of fields. Okay, so just to emphasize one more time that the employability for our students is really excellent. And we have got careers fairs that are organized at the Malaysia campus and also at the UK campus. And employers, they come to the university, they set up booths, and they talk to our students. In some cases, they may hold on-the-spot interviews. In other cases, students can pass CVs, resumes to these external company representatives. And some of them do secure internships as well as graduate jobs from these careers fairs. Okay, so just to show you quickly, just a slide showing you the variety of companies that hire our graduates. You may recognize some of these companies. Okay, so some of them are multinational companies. with presence worldwide, but others are perhaps more regional companies. And our students do very well in securing themselves a graduate position or internships with these companies over here. Okay, so one question that I sometimes get from students, potential students or parents, relates to the aeronautics course. So some of them, they are a little bit concerned about whether there is going to be a job demand. So now, if you look at the worldwide trend, historically, civilian aviation traffic will double. Every 15 years it has doubled, and the trend seems to be continuing. Okay, so regardless of whatever shocks that the world has encountered in the past, economic shocks, financial shocks, yet this trend remains. Okay, so we are very confident that actually this trend is going to continue, because in a more globalized society, globalized world, the need for people to actually travel for work and leisure is going to remain. And our aircraft are also going to be more efficient. It's going to burn less fuel. It's going to be more environmentally friendly. And we actually need engineers, aeronautics engineers who are qualified, who have got the right skill sets to go into these companies. For example, Airbus. Okay, so more specific to Malaysia. So that was the trend on the previous slide, applies to the world as a whole. But even within Malaysia, you can see that back in 1997, we've got only a few companies that are directly involved in the aerospace industry. But come to around 2015, okay, so now we have got a whole range of companies that are now involved. So you can see that this ecosystem is really well developed. And going forward, this trend can only grow. Malaysia as a country that is involved in maintenance, repair, and overhaul for the aerospace industry, this role is going to increase and is going to be, just to summarize, in terms of job opportunities, it can only increase. Okay, just to show you a couple of slides relating to our graduates. So back in 2016, our first cohort of mechanical engineering students graduated. Out of 20 students, 10 of them obtained a first-class honors degree, another 8 obtained second-class upper, and another 2 exited with a B.Eng. So you can see that what our students achieve is really, really top-notch. And often the external examiners to our program, so these are academics from other universities who actually give us feedback as to how rigorous the program is being delivered. So often they remark that students who have gone through the Malaysia campus and transited to the UK campus, they have often done even better than the students who are at the UK campus. Perhaps our students, they get the benefit of a very low student to staff ratio because, we are a very intimate cohort over here. And the lecturers are highly approachable, they are highly accessible as well. So this translates to our students really getting a good experience and achieving good degree classifications at the end of their 4 years. Okay, so this is the second cohort. Okay, so the spread of marks is not shown here, but it is a similar story. So the majority of them graduated with first-class honors and second upper degrees. Okay, so examples of some of our graduates. So there are too many for us to show on one slide, but maybe I'll just highlight one or two. So for example, Jeremy Fong at the top over here, after graduating from the University of Southampton, he secured himself a position at Rolls-Royce. So this is the aircraft engine manufacturer, and he's based in Derby in the UK. So this is a highly prestigious position, really difficult to secure. And he was competing with students from all of the top universities in the UK. And for him to be able to secure that position, this means that there is industry recognition of our graduates. Jeremy Fong, he did really well for himself at the interview, and also he was able to show, based on his marks, his transcripts it really reflects the rigor of the education that he has received. Some other examples, so Tay over here, he's working with a Japanese company, and Junho over here, he joined Ricardo in the UK after graduating. Eugene, so earlier on I had a slide of Eugene, working on that internal combustion engine. So this is him. So he's actually working for an aerospace company, Spirit Aerosystems. And another two of our graduates at the bottom working for GE and Panasonic. Okay, so just to give another example of a student who did really well coming through the Malaysia campus, Aaron Teo, he graduated in 2018. He was my research intern in his second year. So he did a research project with me, and out of that research project, the results, we were able to publish it. So that was a really good outcome. So it wasn't just Aaron, it was Aaron and Anandan, who was another second year student at that stage. So both of them, they came on board on my research project. They were involved for around 2 months, and they built a prototype that allows our collaborators in Singapore to go on to take those measurements, and based on the results of the study, we publish it in this paper over here. Now, Aaron, during his time with us at the Malaysia campus, he also was able to undertake an exchange internship over in Japan. So he was based at the Japan Advanced Institute of Science and Technology, and he was working on another research project related to nanotechnology when he was over there. Okay, so now when he transitioned over to the UK, he continued to do very well, and so much that in his 4th year, he was awarded the best overall performing student. So this was in his final year. Upon graduation, Aaron joined Dyson in the UK, and he's in the R&D, the Research and Development department. So this is really the most exciting field that an engineer could go into. So now, just to share with you a little bit of snippet as to around Aaron as well. So before he joined the Malaysia campus, he was holding on to a couple of offers. So he had our offer, but he was also given an offer to go over direct to the UK to join another highly ranked university. So I remember speaking to him over the phone, and I convinced him that his experience going through the Malaysia campus will be in no way inferior to any experience that he might get going into a top engineering university somewhere else. Okay, and true enough, I think he really benefited greatly from his experience. He performed really well, and he got a good job upon graduation. Okay, so now there are some scholarships available. So I will not really spend too much time over here, but the scholarships are really based on the results that you are coming in with, whether it's A-level results or UEC results or IB. Whichever result that you are coming in with, we'll be able to gauge whether you qualify for full scholarship in the first year, 60% or 25% scholarship. So this, you don't have to apply for this. This is evaluated automatically. And one thing to highlight is that all of the students who come through the Malaysia campus get a transition bursary. So when you go over to the UK in your years 3 and 4, you get 20% off the tuition fees. So this is actually really significant in terms of cost reduction. Okay, so our students on the foundation year program, they get access for scholarships as well. But one thing to note is that students, and bottom row over here, students going from foundation year to the undergraduate program, they are eligible for undergraduate scholarships over here based on their foundation year results. Okay, some students join us with external scholarships coming from some government-linked entities, but some get sponsored by private companies. And some students also apply for these scholarships after joining us, so while they are already students at our Malaysia campus. Okay, so now this is the last slide that I have before I'll show you a short video. This what I'd just like to summarize here is that we offer a very rigorous education in engineering. We allow students to develop their analytical abilities, their problem-solving abilities, and also their decision-making skills, their team-working skills through the projects. They get a chance to develop independent learning, either by accessing the online learning platforms or by doing their individual projects. They end up being highly employable upon graduation. And what we offer at the Malaysia campus is excellent value. Okay, so it's about 60+% of the cost compared to you going to the UK for 4 years. Okay, so this is the last slide that I have, a very nice rendering of the future campus that we'll be moving to. We are very excited about this. This will take place over the next year or so. Okay, so I'll just show you a very short 2-minute video, okay, before we go into Q&A. Okay, so this video that I'll be showing you is a video that was made by the students who were involved in the Formula Student Project. Okay, so that was the Formula Student video, okay, and that was actually produced by our students, and you can see the example of the quality that they're able to achieve in their designs. Okay, so I'll just questions that you think of later. Feel free to look up our profiles on the website. Our email addresses are there. You can always email us with a follow-on question.